All right. So you're talking about in this area here. It'd probably be best. Is it okay if I just erase this and do it again, or so you can ask questions? So oh, that's not working. Okay, now we're on track. All right. So this part here is just a it's kind of like a proof of why the change of base formula works. Okay, so you can accept the fact that this does work and follow along with the proof, but this is the idea. So given this, and this incorporates a couple of the big ideas about logs. So we have log base 5 of 79 equals some number, right? And we're trying to figure out how we can do that with a calculator, because log base 5 is not on the calculator. That's why there's all this log base 10 stuff, because they can't put log base everything, every possible thing in the calculator. It just doesn't fit.
An input though?
What?
Like an input where you put in the base?
Some calculators do, and what the calculator will do is then do this change of base formula, right? But not all calculators do. So, but the reason that this works is this. So this is the big idea that I want to make sure that everybody has, okay, is that this is equivalent to log base 5 of x equals 79. This is what's known as log form, okay, and this is what's known as exponential or power form, okay, that these are equivalent, and you should be able to switch back and forth between these two pretty readily. And you'll notice that all I've done is the base stays in the same position, and the argument and the variable switch locations. Right? Does everybody see that? Okay. Because remember, this set what logs are asking is, what do I have to raise 5 to equal 79? And in this case, we don't know what that is yet, so we say x. Right? Now, one way to solve them, so we rewrote this in power form. Okay, so you should be able to switch back and forth. And then what this is saying is, well, I can rewrite this as 10 to the something, and I can rewrite 79 as 10 to the something, right? Now, and so the way that I'm going to do that is log of 5, right? And what's the base of this log, if it doesn't say anything? Yeah, it's log base 10. It's the common log. And so I can type that into my calculator and say, here we go. And let's turn on large screen. So then I can say log of 5 equals. Okay, so let's see, 0.699. Okay. So then I can rewrite that. So let's say, so 5 equals 0.699 approximately, right? So in other words, 10 to the 0.699 to the x is going to equal whatever the log base 10 of 79 is. So I say log of 79, right? And so I have to raise 10 to this power to make it equal 79, okay? So 1.898. There we go. So we'll go back in here. So 1.898. Okay. Now, what? Now we have that. We have equal powers of the same base, right? So what do we know is true about these exponents? I have the same base, so the exponents must be equivalent. So 0.699x must equal 1.898. That didn't work at all. 1.898. All right, is everybody okay with that? Where, once again, we have a common base. The reason that I did this step was so that I could have a common base, right? And then I could solve this. And realize that this is log of 5, log base 10 of 5, and this equals log base 10 of 79. Okay? So now let's solve. And x is going to equal, what's my only step in solving this now? My last step.
Divided by 0.699.
Right. 1.898 divided by 0.699, right? And this equals the log of 79 divided by the log of 5.
How do we use the function if there's an option that says log and log base? Would that be useful here, or is that?
Yes, it would be.
Okay.
It would sort of skip some of these steps. Now I can plug this all in, right, into my calculator once again, or I can just do this on my calculator, right? And I'll get the log of 79, which is the argument, divided by the log of the base, and that's going to get me this number, 2.714. Now what's that telling me is if I raise 5 to that power, right, and at some point I'm going to have to round, right, so I'll have some little bit of error, 14899. If I raise 5 to that power, I'm going to get essentially 79 with rounding error, right? Okay. And that is why the change of base formula works, and why we use the change of base formula, unless you have a fancy calculator like Tanner Oates. How we use the change of base formula is that, let's say we were given something like this, log base 3 of 54, right? And this is asking the question, what do I have to raise 3 to make it equal 54? Well, I don't have a log base 3 button in my calculator, right? I could even be, let's say I have some number like 3.172, right? Well, if I want to use my calculator to find this answer, what do I have to raise 3.172 to make it equal 54, right? Then what I'm going to do in my calculator, I'm going to say log of the argument divided by log of the base is going to give me my answer, okay? And so then I just go and plug it in, just like it looks like. And I'm going to say log of, 54 divided by log of 3.172. And if I raise 3.172 to the third and a little bit, right, then it will be equivalent to 354. Now, why is all this log stuff so important that they bother with it? Let me see. Hold on a second.